In 5th grade, geometric reasoning focuses on classifying two-dimensional figures into categories based on their properties and creating hierarchies. Students will need to have the following prerequisite skills in order to be successful with the new skills taught in this chapter. All of these skills have been taught previously. The first skill is identify the properties of shapes by parallel or perpendicular sides and specific angle measure and types. Second, build and draw shapes to meet the attributes for a given shape. For example, draw a rectangle. Students will construct a shape with two sets of parallel sides, with two long sides and two short sides. Third, identify specific shapes and sort into basic groups. For example, all of the shapes in the first group have 3 sides, all of the shapes in the second group have 4 sides, and all of the shapes in the last group have 5 or more sides. Fourth, generating Venn diagrams. Each circle represents a specific shape or attribute, and where the circles overlap is where they have the traits in common. One more item to note is the definition of a trapezoid. Mathematicians do not always agree on the exact definition of trapezoids, but for this curriculum, we will use the inclusive definition of a trapezoid. A trapezoid is a quadrilateral with at least one pair of parallel sides. Let's look at the next set of skills students will work on in this chapter. Students will create a hierarchy of quadrilaterals. First, they will start with quadrilaterals, trapezoids, and parallelograms. They will look at the attributes of these shapes and create a Venn diagram to model what the shapes do and don't have in common. Let's place the shapes into each of the circles according to their attributes. The first shape has 4 sides and at least one set of parallel sides, so it is a quadrilateral and a trapezoid, so it will be placed in the overlap between the quadrilateral and trapezoid. The next shape has 4 sides and it has 2 sets of parallel sides. This shape is a quadrilateral, a trapezoid, and a parallelogram, so it will go in the overlap or center of all the circles. The last shape has 4 sides but no sets of parallel sides, so it will go into the quadrilateral only circle. Students will notice that all the shapes are in the quadrilateral circle and that all the parallelograms are also inside the trapezoid circle. The Venn diagram will be adjusted so that the quadrilaterals is the outermost circle and it contains all the trapezoids and all the parallelograms. This can be interpreted to mean that all parallelograms are trapezoids and all trapezoids are quadrilaterals. Students will continue to classify quadrilaterals according to their attributes through the use of Venn diagrams. The Venn diagrams will then be reorganized to create concentric diagrams like this one. Whatever lies within the circle is a subcategory of that circle. For example, rectangles are within parallelograms because all rectangles are a subgroup of parallelograms. Students will take their time in building this hierarchy of quadrilaterals throughout the chapter. It is important to build each section carefully so students can see the similarities and differences of the shapes. For example, look at this square in the diagram. Because it is inside the overlap of rectangles and rhombuses, it too has the attributes of both groups. It also lies within the circle of parallelograms, trapezoids, and quadrilaterals, so it also has all the attributes of those groups. This means that a square is also a rectangle, rhombus, parallelogram, trapezoid, and quadrilateral. Another skill students will learn will be to create a tree diagram. Let's reorganize the concentric circle diagram as a tree diagram. Quadrilaterals will be on the top, linked to trapezoids, linked to parallelograms. Then parallelograms branch out into 2 more subgroups of rhombuses and rectangles. Then the last category of squares is a subgroup of both rhombuses and rectangles. In the last task of the chapter, students will apply their knowledge of creating a hierarchy of quadrilaterals to creating a hierarchy of triangles. Finally, students will bring together both hierarchies to create a hierarchy of polygons. Polygons are any closed shape with at least 3 sides. In 5th grade, geometric reasoning focuses on classifying two-dimensional figures into categories based on their properties and creating hierarchies. Students will move from categorizing a shape based on what it looks like to categorizing it based on its attributes. This is an important concept and should not be rushed through. Students need time to build the connections.